Okay. Hello again, calculus. So we are still working with section 3.1. So there's not really anything new to teach about this section. I just split it up into two parts to make the homework more manageable and make sure that you had mastered some of the easier problems that you did for class on Monday or on Tuesday. I'm sorry, and that we will go over in class on Tuesday. And then these problems are just a little bit more involved. So, and I say that because they involve the trig functions, so that generally doesn't come as easily to everybody. So you might think they're just as easy as the rest. To do these problems, the one we're going to do together is as hard as they get. So the ones that are in your homework are, for the most part, much simpler and much shorter than this trig problem that we're going to do together on the board. But when we're doing the trig problems, remember that it is helpful to have in front of you the trig identities, as well as the derivatives for some of the trigonometric functions. So one of my classes, I was on my A game and handed it out to you last week. The other class, I totally forgot. So I know when you had, well, I don't know, I think when you had Mr. Singleton, that he would probably have posted those materials for you, but I'm just going to put into the chapter 3 folder on Schoology the table that I like to use when I'm dealing with derivatives with trigonometric functions. So you'll find that there, and it's just a nice resource or reference to have with you when you're solving these problems. So we're doing the same kind of thing. So the function we're going to use, I have notes this time so I can just write down my answers and not have to awkwardly walk over and look or use a calculator. So the function we have is this. F of x is equal to 2 times the sine of x minus the cosine of 2x, and we want to evaluate this. So we're looking for the maximum and minimum value on the closed interval 0 to 2 pi. Okay, so we go through the same steps that we did in the previous PowerPoint. So we first take the derivative of the function, and we want to find our critical points. Remember, critical points are any points where the derivative of your function is 0 or undefined. So I'm going to take the derivative of this. So the derivative, 2 times the sine of x. So the derivative of sine is cosine. So this would be 2 times the cosine of x. Minus, now here I have to use the chain rule, so the cosine of 2x. So I'm going to start out and work my way in. So the derivative of cosine is negative sine. So minus negative sine of 2x times the derivative of 2x. So it's like times 2, right? Now this is really ugly the way I wrote that. So let's clean that up. So the derivative of the original function is equal to 2 times the cosine of x minus negative, so let's say plus, and let's move this 2 out front to make it look nicer. So plus 2 times the sine of 2x, right? And we want to know when this is 0. Now, at this point in our process of finding the critical point, at this point our calculus is really complete. So now we are going to evaluate where does this equal 0. And as I said, this one's a little bit longer and more involved than most of the problems you're going to see in the homework. So when I'm looking to figure out when is this 0, you know, you need to think about some trig identities. This thing you really can't simplify any further. 2 times the cosine of x, that's as simple as it can get. This one, however, that's a little bit trickier. And so if I had my trig identities in front of me, I would remember that the sine of 2x is equal to 2 times the sine of x times the cosine of x. And so that's what I'm going to use here. So I'm going to say 0 is equal to 2 times the cosine of x. So I did not change that first term at all. And then this is going to be plus 2 times, and instead of writing the sine of 2x, I'm going to use that trig identity. 2 times the, it doesn't matter what our order is, let's say cosine x times the sine x. I think, now this is where I'm proving myself to be a science teacher and not, I haven't seen math in a while. I think I use that a lot. I think it's called the double angle theorem, as I recall. But it's something you should have seen before, right? And so when I take a look at this, I see that I can factor out a cosine of x. So I can say, okay, 0 is equal to 2 times the cosine of x plus, times 1 plus 2 times the sine of x, right? And so then I want to solve this. Oops, I'm going to scoot it over so we have a little bit more room. I'm going to solve this to find those critical points. Okay, so when I look at this full function, I'm seeing I could have several critical points. I'm going to have a critical point when the cosine of x is 0, right? Because then that makes this whole term 0 and I multiply by 0. So where does the cosine of x equal 0 on this closed interval 0 to 2 pi? So this is where you, it looks like from grades from last quarter, you spent some time reviewing the unit circle. These values should be in your head. You can always go and look them up if needed. So the cosine of x would be 0 at your kind of your 90-degree angles. So that's on this interval, it's going to be pi over 2, and then 3 pi over 2. And then the other place that we're going to have a critical point is when 2 times the sine of x is equal to -1, right? Because then we're going to have 1 minus 1, and that's going to give us a 0. And so this means when the sine of x is equal to -1/2, and in radian, I'm so used to these in degrees because that's what you use in physics primarily. In radian form, that's going to happen in 2 places. So this is, I want to say 7, I have it in front of me, 7 pi over 6, yeah, and 11 pi over 6. So it's like 330 degrees. So I end up with, sorry, I'm going to scooch this even more. Let me try killing the lights so we kill that glare. There we go. And so I end up with a total of 4 critical points. So I need to evaluate this function for its maximum and its minimum at 6 points, at these 4 critical points, plus the 2 endpoints, right? So I'm going to do f of 0. Let me stick with the order I have in front of me. F at pi over 2. I'm trying to put them in order. It doesn't really matter. F at 7 pi over 6. F at 3 pi over 2. F at 11 pi over 6. I forgot the pi, sorry. And F at 2 pi. So this is tedious. I just have to plug all of these values in to my original function. You just crank them out on the calculator if you want. And see what I get at all 6 of those points. And so when I do that, I will get a -1 when I put the 0 in, a 3 when I put it the pi over 2, a -3/2 at this value, a -1 at 3 pi over 2, a -3/2 here, and a -1 at 2 pi. So I see a clear maximum value. This is my maximum value, right, at 3. And actually what I have here are 2 minimum values, and that's fine. So these would be local mins, is what we call them. I hear that he's up, Toby. So I have minimum value at 7 pi over 6 and at 11 pi over 6. And so this is what I could do with a trig function. Again, most of the trig functions that you're going to be working with in the homework are like half this long, right? Because you don't have to deal with the identity theorem that makes this factor and get really long. So they're much simpler functions, but you should be able to handle something like this. So if you have any questions, definitely let me know. Otherwise, kind of exploring with the homework is the best way to do it. Now, there's one more problem I want to walk through, and this is really just a repeat of the last. I'm going to, pop down to the next slide. This is using this concept in a word problem. Now, later in the chapter, we're going to do something called optimization problems. And optimization problems are where we really can use this concept and some more that we'll keep learning. So I'm holding off on more of the real-life applications until we get into those optimization problems. Any of you in this class who are studying business, this is like business calculus, you do a lot with it. But I want to show you one really simple one now, because I did give you one word problem in this second set of homework. Okay, so this one was about an oil company, and it says that the oil company or oil refinery has a function for their daily profit. And the function is given like this. P, where P is their profit, is equal to 8x minus 0.02x squared, where x is the number of barrels of oil that they're refining. And then obviously they would go on to sell. Oh, I see that you can't see my function. Sorry, there it is. Okay, so And they can refine a minimum of 0, right, if they do nothing all day, up to a maximum value of 400 barrels a day. Now there's obviously a cost for them to do each one of these things, and then whatever the market is and how they sell. So here's this particular function that this company has for their profit. So they're not necessarily going to get the most profit out of refining the full 400, depends on the market, etc. And so we want to use the function they have for their profit and we want to maximize it. So we want to find how many barrels should they refine in a day to get their maximum profit. So to do that, we want to find the maximum value. And to find the maximum value, we first need to find the critical point. So we're going to take this function and we're going to take the derivative. Now this is much simpler than the one I just did, right? So the derivative here, the derivative of 8x is 8. The derivative of 0.02x squared would be 0.04x. We keep that negative sign in as we subtracted. And I want to find where this is equal to 0. So we say 0 is equal to 8 minus 0.04x, which means that x is equal to 8 over 0.04. And this gives me 200. So 200 is my only critical point for this function. And so I want to go back and evaluate the original function at the endpoints and the critical points in order to find my maximum value. So I want to find p at 0, p at 200, and p at 400. So p at 0 is 0 if we look at the function, and that makes sense. If I don't refine anything or sell anything, there's going to be no profit. So just thinking logically, that makes sense. P at 200, if I plug 200 into this original function and plug and chug, out I get an 800, I believe. And 400, if I put 400 in, so I put whatever I can, that's the max they can do in a day, it actually turns out that I get 0 profit. And so the maximum is at 200. And so if you are this company, that's how many barrels you would want to refine in that day. Now the word problem I have you working on in this homework set is actually a physics problem, so I love it. It deals with power and current. And I'm actually going to talk to you a little bit about it on Thursday. Had to think when I see you next. On Thursday, and sort of explain how that works. They're going to talk, you don't need to know any physics to do this problem. If you are in physics, I haven't taught you the physics to do this problem. So it's an electricity thing. But we will talk about what those quantities mean on Thursday. But in the meantime, actually solving the problem, if you just try to ignore, that you might not know what those terms mean, like volts and current and amps, etc., just solve it with the function they give you. It'll be something like this. It's actually a p function. Take that derivative, maximize it, and see if you can get the answer with that approach. Okay, see you on Thursday.